So we are running the error backpropagation, and how do we update the weights between the hidden layer? How are these weights updated between the hidden layers? So how can we do that? So how can we update the weights between the layers? For example, if we are here at this point and we have to do the backpropagation to update the weights. So for this part, we first take the error with respect to your net function, and your net function with respect to your weights w, k, j. So this is the partial with respect to weight value this, and we can replace this value with delta k, represented like this for simplicity. And for the weights in the previous layers, similarly, we can point them out. Like for this weight, we have to consider the error with respect to your net, and then from net you can get your weights w, ji, partial derivative, and again this value is replaced by delta j, represented like this, and finally we will be at the, and for this again the rule will follow. We have ni, h of ni, so we take the partial of the error with respect to ip, wip, which is the partial with respect to net, and then partial of net with respect to your weights wip. Again delta I is represented over here. So now for the ease of representation, let's look at this. We know that delta k is partial of error with respect to partial of your net. So partial of error net is actually your partial with respect to your h and k, and then h and k with respect to net nk. And similarly your delta j, it would be partial with respect to h and j, and then partial of h and j with respect to net and j. Finally, for partial of I, for this layer, the weight value updates would be first your h and j error with respect to h and I, and then your partial of h with respect to net and I. So there is a link between the layers, and the general rule is generally we can say it is the same. So we are trying to find a generalized form of representing your weight updates using backpropagation. Here we can see so your delta k is represented in this format, and for delta j we know that it is error with respect to nj, and then from nj you go at net nj, like I explained earlier. So how can we represent this? So with respect to h of nj, you can see your error. First you calculate with respect to your net function, and then from your net function you're going to your h of nj. So this is the general rule, because we know that your net with respect to h and j becomes wkj. I explained earlier. So this is basically your h. So if we take the derivative with respect to h, you will be only left with weight values. So at this layer, at this point, you're going to be left with your weight values wkj, and this part we can represent as delta k. So for one previous layer, we can simply use this function and then multiply with your kj, and this part will remain from the existing current layer. Similarly, if we move on to the next part, so for your delta with respect to h, which is basically from error you go to net, and from net you go to h. So again, partial of net with respect to h, you are left with w ji at this layer, and then delta j, which is your previous function. So there is a link, and then you have a multiplying factor h with respect to net. So if we summarize, we can write like this. If you want to take the first layer, second layer, hidden layer, sorry, n minus 2, n minus 1, and n, if you have 3 hidden layers, so it will be like this. The last layer will have the form delta k, h, and j. And your ji will be h n I multiplied by your delta j, and for this part you will simply use delta I h n p. So it goes like this. And then we can represent our delta k here as your partial of with respect to h, and then from h you go to net, as explained here. So this part remains the same, and we can represent that this single neuron has to take the sum of all the neurons from the previous layer in your multi-layer perceptron. Therefore, we take the values from 1 up to k, all the neurons in that layer, okay? And you multiply your delta k with your weight values. Similarly, for the layer before that, here you can update by taking all the neuron values. You can take the delta j and multiply by the weight values, and here your h function with the partial with respect to net will remain here. So there is a pattern in finding your weight updates for the hidden layers. So the first we have devised your delta nk and h of nj. So for kj you need the previous one h and j, and you need your delta nk from this layer. Again, for this layer you will need these h and I values and your delta from this layer, okay? So this pattern goes on like this. And then for delta nk, now we define delta nk. What will be the delta nk? It is basically your error function with respect to h, and then from h you go to net. Fairly simple. And we all know that whenever we take a partial of a value with respect to the net function, for example here the net function is your sigmoid. If you take your h as sigmoid, so in this case this is equivalent to h of nk 1 minus hk, and your e with respect to delta h is represented like this. For explanation of this, how we go from here and how we go from here, it is present in the previous lecture, so you can visit slide number 33. So start studying from slide number 30 onwards, and you can find the explanation as to how we get these values.